What are GS units? GS units are used to measure dirty electricity, and they are presented here as a function of voltage and frequency. This research was done by Magda Havis and Ralph Frederick, both at Trent University in Peterborough, Canada. The Graham-Stetzer filter and the microsurge meter were designed by Dr. Martin Graham, Professor Emeritus at UC Berkeley, based on discussions and joint research with Dave Stetzer, a power quality expert and president of Stetzer Electric in Blair, Wisconsin. The microsurge meter is an inexpensive tool designed to measure poor power quality, commonly referred to as dirty electricity, on electrical wires. It works optimally for frequencies between 4 and 150 kHz. The microsurge meter on the left shows a reading of 488 GS units. The Graham-Stetzer filter reduces high-frequency transients and harmonics on electrical wires and thus improves power quality. It works for frequencies between 4 and 100 kHz. With one GS filter plugged into the same circuit, the dirty electricity drops from 488 to 339 GS units. Why was this range selected for the filters? It was based on Russian research which shows that at frequencies above 2 kHz the energy flows internal to the body and is much more harmful. For this reason, Russian guidelines for electric and magnetic fields are lower for frequencies above 2 kHz than they are for frequencies below 2 kHz. What levels of GS units are safe? According to our research, levels below 40 have been associated with reduced blood sugar among diabetics and reduced tremors among those who have multiple sclerosis. However, levels below 25 are required by those who are extremely sensitive. The electromagnetic spectrum is divided into different frequency categories, with extremely low frequency at the bottom, followed by radio frequency that overlaps with microwaves and radar. Infrared radiation and visible light complete the non-ionizing part of the electromagnetic spectrum. Ultraviolet radiation as well as X-rays and gamma rays are ionizing, which means they have enough energy to break bonds within molecules and to damage DNA. The two frequency bands within the non-ionizing part of the electromagnetic spectrum that have received the most attention include power frequencies at 50 and 60 Hz that fall within the extremely low frequency band, and microwave radiation at the upper part of the radio frequency band associated with technologies used for wireless communication and heating. The World Health Organization recognizes another band of the electromagnetic spectrum classified as intermediate frequency that includes 30 Hz to 10 MHz. Poor power quality or dirty electricity falls within this range of intermediate frequencies. What is a GS unit? According to Dave Stetzer, a GS unit is a measure of the energy on electrical wires generated by high-frequency transients and harmonics and is influenced by voltage amplitude and frequency. What we did. We took a frequency generator, dialed in a frequency from 2 to 120 kHz, altered the voltage, measured power quality using the microsurge meter, and graphed the results. Figure 1 shows poor power quality measured in GS units as a function of voltage at different frequencies. The voltage is measured in millivolts root mean squared. As voltage along the x-axis increases at any one frequency, the dirty electricity increases in a linear fashion. The slope of the lines is a function of frequency, and as the frequency increases, the rate of change increases as well. The values are linear up to 1,750 GS units. Figure 2 shows power quality measured in GS units as a function of frequency measured in kilohertz at different voltages. As the frequency along the x-axis increases at any one voltage, the dirty electricity also increases in a linear fashion. In Figure 3, we plotted voltage along the x-axis against frequency along the y-axis for 4 GS units, 2,000, 1,000, 540 GS units. The equations and R-squared values are provided. Figure 10 shows all three graphs and the equations and the r-squared values within the linear range up to 1,750 GS units for each frequency in Figure 1, each voltage in Figure 2, and both frequency and voltage in Figure 3. Another argument we hear is, but the energy is on the wire and doesn't radiate through the air into the room. If that were the case, how do you explain the following results? We took a fluke scope meter that has two channels, and we took a light bulb to measure what radiation was emitted from the light bulb. We took one of the channels, hooked it up to measure what was coming out along the wire. We took another channel to measure what was actually emitted through the air at 0.5 meters from the light bulb. We did this research in a rural area of Wisconsin where there are no cell towers and very other sources of interference in our testing. Everything that is in red is what was coming out along the wire. Everything in blue shows you what was coming through the air. The reason the wire is not modulated in a 60 Hz fashion is because we used a ubiquitous filter designed by Dr. Martin Graham to remove the 60 Hz cycle and then show us just the dirty electricity on the wire. We got this waveform whether the light bulb was turned on or off. When we used a compact fluorescent light bulb, in this case it was a General Electric 15-watt light bulb, this is the spectrum that we obtained. Everything in red is coming from the wire, everything in blue is coming through the air. The dirty electricity in the first example with the incandescent light bulb measured 65 GS units, and this was the case whether the light bulb was on or off. This light bulb does not contribute to dirty electricity. However, with the compact fluorescent light bulb, the dirty electricity jumped to 298 GS units. When we took this light bulb and plugged in one GS filter, this is the spectrum that we observed. With one filter, the levels of dirty electricity on the wire and the amount of radiation coming through the air were both significantly reduced. The dirty electricity dropped from 298 to 26 GS units. And this is what the spectral distribution looked like for the same light bulb. You can see here a number of high frequency bands that are showing up in the spectral distribution. Once again, when we took that compact fluorescent light bulb and introduced one GS filter, we significantly reduced the amount of energy radiating through the air. What this clearly shows is that the energy radiates through the air and can be reduced with GS filters. For more information about dirty electricity, visit the following websites. Thank you.